Hello everyone, in this video we'll be solving problem 13 Roman to integer. The problem statement is we are given a Roman number in a string form and we need to return its corresponding integer value. Here's the lookup table that we can use for reference where each character is represented by a different value starting with I is equal to 1 all the way to m is equals to 1000. In example number 1, the input s is 3 i's, so its corresponding value is 3. Because each I represents 1, so if we add them together, it gives us an output of 3. In example number 2, we have L, V, I. L is 50 and V is 5. So if we add the corresponding values of each character, the total will be 58. Let's switch to whiteboard and understand different patterns and how it can be solved. The simplest way to solve this problem is to take the corresponding value of each alphabet and add it with each other, and the total will be our output. For this input, the corresponding values for each characters are x is 10, v is 5 and I is 1. Adding them together gives us the total of 38. This sounds like a very easy problem, but there is one edge case that we need to take into account when we are implementing the solution. There are a few combinations of Roman numbers whose corresponding output will not be correct if we apply the same principle. For numbers like 4 and 45 whose equivalent representation is IV and Vx, the same principle will not work. For instance, if I try to apply the same principle on 4, that is IV, my total will be 6. I is represented by 1 and V is 5. Adding that together will give me 6. But the actual output should be 4. So we need to make sure a solution can handle these cases too. One simplest way to identify if we can use the addition approach is by comparing the current character with the next character. The addition approach can only be used if the current character is greater than or equal to the next character. And if the condition is not satisfied, then we need to subtract the current value from the total. If we look at the example number 1, starting from left to right, each character and its corresponding value is actually equal to or greater than the next one. X is equal to the next x, which is also equal to the next x, which is greater than v on position 4. So we can apply the addition rule here without getting skewed results. But on the right hand side, with IV as an input, I is smaller than v. So instead of doing an addition operation, we'll subtract the value of I from the total, giving us the total of 4. If we apply this principle on this input VL, value of V is 5 while L is 50, as 5 is smaller than 50, we'll decrement or reduce 5 from the total, giving us the output of 45. I hope you are now able to understand the two operations and when to apply which to get the correct results. With this solution, our time complexity is O of n, where n is the size of the string and space complexity is O of 1. Let me show you how we can implement this using C#. Here is my C# solution. I've initialized a dictionary to maintain the map of all Roman characters and its corresponding values, which will be used to do lookups in the further implementation. I then start a for loop with I is equal to 0 until I is less than s.length minus 1. In the for loop, I am first checking if the current character that I is pointing at is it greater than or equal to the next character. If it is, then I am adding the current character's value to the return value variable. If not, then I am subtracting its corresponding value. As we are only running the for loop until s.length minus 1, we still need to process the last character. So I'm adding its corresponding value to the return value variable at the end and then returning the output. This code, when submitted on LeetCode, beats 28% of the submissions in terms of runtime and 24% in terms of memory consumption. Thank you for watching this video. I hope you were able to understand the solution and the explanation. I hope you were able to understand this explanation and the source code. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.